Anything about the Parker Solar Probe lately? What's up with that? Parker Solar Probe, named for Eugene Parker. He's a solar physicist who, back in the 1950s, proposed the crazy idea that maybe the sun is releasing particles from its surface in the form of what today we would call the solar wind. And these particles would stream out through the solar system and collide with planets, possibly generating Earth's aurora. Well, how are you going to confirm all this? You can use telescopes, but you really kind of want to go there. Well, that's hard and dangerous because, why? The sun is hot. Finally, the engineering came to pass. The design and construction of this remarkable space probe became a reality. The reason why I'm talking about it is the Parker Solar Probe just made its closest approach to the sun. And how close was that? The closest we've ever sent anything to the sun. 5 sun diameters away. And since the sun has such a huge gravitational field, anything that flies that close to the sun, its speed increases from the gravitational attraction of the sun. And as a result, the Parker Solar Probe has reached the highest speed ever for any human-made craft and hit a top speed of 430,000 miles an hour. So how fast is 430,000 miles an hour? That's fast by terrestrial standards, but in the universe, it amounts to 6/100ths of 1% of the speed of light. So get over it. The point of this is not to show off how fast it's moving or how hot it's become. It's to make measurements of the sun to more deeply understand what we call solar weather. The storms on the sun release particles into space that actually have a way of heating the outer atmosphere of the sun, which we call the corona. The corona is what's rendered visible during a total solar eclipse. It's millions of degrees, much hotter than the sun's surface, for reasons that remain a little bit mysterious. However, it's very sparsely populated by gas molecules. How hot would it feel? I don't know. If a particle hits here and then there, you're not bathed in a complete solution of hot gas if you were in the corona. And it's likely that you could just survive it just fine, even though it's millions of degrees. What would be much more damaging to you and devastating is the radiant heat coming from the surface of the sun itself. And the Parker Solar Probe, why doesn't it melt? Because it's shielded by the substance, the element on the periodic table that has the very highest melting point. What could it be? Is it some metal? Is it the highest melting point element on the table by far is carbon. So there's a carbon composite shield there, rather thick, but nonetheless to protect it from the sun. It is there, always oriented in a way to shield the rest of its electronics, to make the measurements of the magnetic field, the particle flux, the whatever might be the heating mechanism for the corona. It's the sun close up and personal. And I guess we can say that's touching the sun because the corona is part of the sun's full atmospheric structure and size and shape. But when you're told a probe is touching the sun, what are you thinking? You're probably thinking it's going to skim the surface of the sun. It's like, no, that's not. It's going to be 5 solar diameters away from its surface. Little human interest fact that there's a little memory card that is flying on this mission that has a photo of Eugene Parker, a file containing his original paper he published in 1958, making some radical predictions in what would become the solar wind, as well as the names of 1.1 million people that want a little piece of themselves, their name, to participate in the exploration of the solar system, and in this particular case, to kiss the sun. The sun, the nearest star in space to Earth. The more we understand it, the better able we will be to accommodate the idiosyncrasies of the sun's cycle. Its 11 and 22-year cycle. Some of it remains a bit mysterious to us. We're scared a little bit because explosions on the sun can send a flux of particles that will have the power to knock out much of our orbiting satellites, unless the satellites are electronically hardened, as the expression goes. So we are particularly susceptible in modern times, given how much of our economy and our national security depends on space assets. The more we know about space weather generated by the sun, the better off we will be. And so that's a little bit of what's up with that.